I'm Chris Anderson at the EU Web Tech Lab, and today we'll discuss ROHM's BD9G341AEFJ, a single-channel buck converter with an integrated FET, a wide input voltage range, and output voltage that is variable from 1 volt to VCC at 3 amps. The BD9G341AEFJ implements a current mode architecture, providing fast transient response and a simple phase compensation setup. Design is further simplified by integrating an 80 volt, 3.5 amp, 150 milliohm N-channel MOSFET. The input range of 12 volts to 76 volts allows the device to be used in distributed power applications and eliminates intermediate conversions and the associated loss in total conversion efficiency. It is also well suited to battery-powered applications due to its 0 microamp standby current draw. Now, on this hardware, you can see just how simple the implementation is. On the board, we have the converter, the output diode, and the output inductor. Beyond that, there are just a few small passives. This is a 47 kilo ohm resistor, which sets the clock to 200 kilohertz. If you decrease this resistor, you increase the clock frequency, which allows you to reduce this inductor, which then allows you to reduce the size of your implementation. For the setup, I have this DC load set to draw 3 amps, and I have the output of this triple output power supply across the positive and negative voltage, so I can get up to 50 volts. The output is set to track, so as I adjust one, it actually adjusts both. So the voltage on here is twice what's displayed. So if I turn this on, so you can see that we're at 25, which is really 50 volts. We're drawing 3 amps. This says 4.8 volts. So if we probe the output, you can see on the meter that we're actually at 5 volts. Now, if I ramp my supply voltage down, and remember it's twice what it shows on here, as we get down to, say, about 9 volts, if I step this down again, it's going to hit the output limit of the actual supply. So it'll start switching between constant current and constant voltage modes. But if I ramp down far enough, you'll see that this has gone into under voltage lockout. Now, beyond under voltage lockout, it has all the other standard protections you'd expect, including overcurrent protection, over voltage protection, and thermal shutdown. Now, to help with the thermal aspect, the underside of the package has a thermal pad which helps pull the heat out of the package. If I go ahead and ramp this back up, we'll just take it all the way up to 50 volts. You can see that we're back into conduction. If I pull this jumper and set it to the other side, that will actually put the device into standby mode. And so you can see that it's turned off. You can see that my supply is still registering 1 milliamp, but even if I disconnect it, it still registers 1 milliamp. That 0 microamp standby current allows you to have a higher efficiency in your designs. ROHM's BD9G341AEFJ accepts a wide 12 to 76 volt input and reduces design effort thanks to its integrated FET and current mode architecture. A switching frequency up to 750 kilohertz allows for smaller inductors and provides high efficiency variable output voltage from 1 volt to VCC with 3 amps of current. For more information, visit rohm.com.